Docker. Next. Docker is gaining the popularity and its usage is spreading like wildfire. These are all okay. I took it from site. Okay. And Docker is one such tool that truly lives up its promise of build, ship, and run. Okay. Okay, let's go to the next one. Docker is a software containerization platform, meaning you can build your application, package them along with their dependencies into a container. Then these containers can easily be shipped to run on another machines. These containers uses containerization, which can be considered as an evolved version of virtualization. The same task can also be achieved by using these virtual machines. However, it is not efficient. Means we know about virtualization very well. VMware Workstation, VMware ESXi, we are creating the virtual machines on that by using some different operating systems.
Yeah.
You are running a Windows 10 as a host operating system, but within that you are running the CentOS as a guest operating system, guest OS. So this running within the same like a different operating system is possible through the virtualization. So we are doing it through the VMware Workstation is giving us like personal use like that. And what normally we do for a virtualization, we will give the CPU credits for that. Maybe like 4 CPUs will assign it, and near about 4 GB or 6 GB something DRAM will assign that. Some 200 GB to 400 GB something the hard disk will assign that. Means like it's like creating an extra machine within a machine. That's what we are doing it. That is called as actually who is maintaining that in the sense there is one device in between there. That is called as a hypervisor.
Yeah.
So the hypervisor is allowing a host operating system can run multiple guest OS on top of it. It may be like very much technical. Say for example,
if it is type 2 hypervisor, even type 1 also the same. Yeah, then there is no guest OS.
Host OS.
Yeah.
Here the hypervisor will be standing.
Yeah.
Here the VMs will be sitting on 1, 2, 3 like VM1,
VM2, VM3. Yeah.
All are talking through this hypervisor to the host OS, and again the host OS will be having the CPU, memory, and the motherboard and other functions and everything, the network card and other things. So, but still the VMs are utilizing the base CPU, base memory and other things, but they are allocated certain things with that. This is the older, for last 15 years we've been using all this virtualization like that.
Yeah.
But there are some drawbacks in this, pros and cons in that, that we are going to see it in the next slides. Next. What is virtualization? It's a technique of importing guest operating system on top of host operating system. This technique is a revelation of at the beginning, but because it allowed developers to run multiple OS in different virtual machines and all running in the same host. This eliminated the need for extra hardware resource. Only extra hardware resource is not required. Whatever we have, like you are currently running the CentOS on top of Windows 10 by using the VMware virtualization, VMware hypervisor like that. So advantages of virtual machines or virtualization are multiple OS can run on the same machine. Maintenance and recovery were easy in case of failure conditions. Total cost of ownership was also less due to the reduced need of the infrastructure. Within the same hardware, we will be distributing that, sharing that CPU resource, the DRAM resource, hard disk resource like that. We just sharing it accordingly. Whichever the OS is demanding heavily, like we will be allocating it. So this is about the virtualization part. Next. This is how it works. So here you see the host OS.
Yeah.
This is now it is your Windows 10. You can take it as.
Yes.
It's running with an hypervisor. That is your virtual VMware workstation.
Yeah.
These are all the VMs. VM1, VM2, VM3. Like this. So this guest OS, on top of the guest OS, the binaries and library files are running. On top of it, the application is running. The same way like for here, like for here. What is the advantage is that they are all means properly shared with every other resources on the hardware. They can run it on the same machine itself. So this is the idea behind the virtualization of it, which we were running for last 10-15 years ago. What is now is being made, we will see it on the next slide, has some shortcomings. Running multiple VMs in the same host operating system leads to performance degradation. Definitely, you'll have some hanging, you'll have some memory utilization heavy, CPU hike is going on 100%, something like that. So this is because of guest OS running on top of the host OS, have its own kernel and set of libraries and dependencies. Kernel is nothing but an OS. Takes up large chunks of system resource, that is hard disk, processor, and especially RAM. Another problem with the virtual machine use is it takes almost a minute to boot up. Booting will be timing, it will take its own time. This is very critical in case of real-time applications. Booting time they are talking about. But what do you say? When we started the VM and all, we never shut down. So booting time doesn't make any sense at all. We have ESXi services running on that. In that we will have that VMs are running for years and years they are running. Okay, anyway, this is also one of the concern to come to the containerization. Let's go to the next slide. Following are the disadvantages of virtualization. Running multiple VMs lead to unstable performance. Hypervisors are not as efficient as the host operating system. Boot up process is taking long and takes time. These drawbacks led to the emergence of new technique called containerization. We will see what is containerization. Next. What is containerization? Is a technique bringing the virtualization to the operating system level. While virtualization brings abstraction to the hardware, containerization brings abstraction to the operating system. So it is different than the hardware things. Do note that containerization is also type of virtualization only. I need to add that word called only. Okay, anyway, I can type it. Containerization is, however, more efficient because there is no guest OS here. No guest OS. And utilizes the host operating system itself. Fuck, it is screwing the OS there. Share the relevant libraries and resources as and when needed, unlike virtual machines. This is the best difference. Application-specific binaries and libraries of containers run on the host kernel, which makes processing and execution very fast. Even booting up a container takes only a fraction of a second. Because all the containers share host operating system and holds only application-related binaries and libraries, they are lightweight and faster than virtual machines. Now you know the difference between the virtualization and the containerization. Virtualization completely hardware based. Containerization completely software based. That is the only difference. And there is no OS in the containers. There will be no OS at all. OS will be the host OS only will be utilized. But what the containers will contain? They will contain their own libraries and binaries, something whichever it is exe file. We call it as exe in Windows environment. .bin files in the Linux environment. That is the binaries. Binaries and libraries will be intact, but those binaries and libraries will utilize still the host OS operating system kernel only. So that's why it is very easy to share it between the machines. We can import it, we can export it, we can pull it, we can push it. Like it depends on the hardware like that. So then they are lightweight and faster than virtual machines. Definitely they are lightweight. They don't carry the entire OS with them. If you're having the OS in the sense, minimum 500, 600 MB will come, right? Along with the OS, then again the application, then again the binaries, then again the libraries. Everything will be coming around 1 GB. But in our containers, if you see that, even we can have the containers in KB level, kilobytes level we can have, and we can have it in MB levels also. It depends on the application which you are going to use that. So what is the containerization? Is bringing the virtualization to the operating system level. Virtualization is abstracting the hardware. Containerization is abstracting the operating system.
Yeah, I have a doubt here.
Yes.
Let's say that so it also should carry the operating system, right?
No, it will not carry. Containers will not carry.
It doesn't carry. Yeah, that is well understood. Then how does it work exactly? Because thing is now operating system. It moves from one, let's say, one place to another. The application. So let's say one host to another host, right? Like in how vMotion happens in VMware and all. Right, same way this happens. In VMA also, that doesn't carry the operating system. What it does is, so that will keep in the
No,
storage.
vMotion is for, we are actually, what is that? Migrations only we are doing on a vMotion, right?
No, when the hardware utilization goes high also, that guy will move that VM instance from one host VM host to another VM host. But yes,
It is very much possible. See, you are talking about that entire OS virtual machine you are migrating from here and there.
agree.
That when you are migrating the VM, what happens? It takes the OS, like binaries, libraries, everything along with it. Like they are vacating one home and they are going to another home like that.
Yes, exactly.
Got it. But that will be very harder. Why? Because of the size of that entire box VM. It's called as a virtual machine. It is not called as a container.
No, it's not
What
container.
is the difference in the container in the sense? Container doesn't have the OS at all. Container will have exe file and whatever the necessary files to run it, like a library, DLL files we call normally. Dynamic link library files. Application, say for example, you can take it like a Adobe Acrobat Reader. There is an application, no?
Yeah.
Now that application can be installed in anywhere. It uses only the operating system.
Now,
You
if
can
you
install
have,
it in Linux.
yeah, if you have if you have a container, so we can install that application in that container. We don't have to worry about the operating system, right?
Yes, operating system will be utilized by the base operating system where we are installing this Docker container, like that.
Docker container. We don't care
And
that
that
Docker is.
container, yes,
We
and
don't
that
care that.
container will use that OS. Will use the OS.
Okay. When
And
the
will
time
use
of
the OS, will use the hardware, will use the network interface card, will use the RAM, will use the CPU,
everything, but it is through OS. Not
through
that
OS only. OS will control. OS actually, take it like this. The OS treat that container as an application running. That's it.
Yeah, okay.
A very simple term, but I cannot say that word. It is technically wrong. Applications are different. Applications are different.
Yeah.
Application
I
in the sense
understood
I'm
that.
taking.
I understood
Yeah.
the
Application
concept.
in the sense I'm talking about Microsoft Office. Like, and this Zoom application, and this what are the games which you are playing on. These are all like an application comes into our operating system. We are installing it. But they take
This
the
is
CPU
like,
resource, the
yeah.
OS, and everything. They will take it. But we cannot compare the application to the container. That is, the container is completely different. Container is about to do some kind of operations for us. It is going to be get developed some new things. Like there is a developing a new software, something like that. It goes on. That is a different issue. But you can easily understand. That's why I said that the container.
Yeah, it's like next generation vMotion.
Yeah, you can say that. vMotion, see, you are sticking in the way because we are all from VMware. Okay, I understand. We are all VMware people, VMware child. We know only very easily the VM will understand because we, like allocating the hardware for that, RAM for that.
Yeah, that's it.
These are all we are doing that. We've been, what actually you are doing in the sense, inside a machine you are running multiple machines.
Yeah, that means we have to
sharing the resources. And sharing the resources from the original resource. 16 CPU is there means 4444 CPU you will give it.
Yeah.
16 GB in the sense 2 GB you will give it. Right. 4 TB hardware, 4 TB hard disk in the sense 1 TB you will give it. This is what we were doing it.
Yeah, we cannot compare this.
Virtualization. This is called as a virtualization.
This is not
virtualization. Is the older technique as of speaking, because virtualization still requires the base OS need to be installed. Linux OS has to be installed, Mac OS has to be installed, Windows OS has to be installed on top of the host OS which is running in the backend. Got it?
Yeah, well understood. Thank you.
In container there is no OS, no OS, nothing. Clean. It's only application. Take it in there.
Yeah.
Okay, now let's go to the next slide. Advantages of containerization over virtualization. Containers on the same OS kernel are lighter and smaller. Better resource utilization compared to the VMs. Boot up process is short and takes only few seconds. You see that this is the container. Container engine is the host OS is sitting down. It's normally with its own CPU and RAM and hard disk. Everything is sitting here. But this guy is like an application is running with his own binary and the libraries is coming and sitting on top of the container engine. So 3 containers are running in the same host OS, and they are not dividing the things. They are not getting allocated to that whatever they require, something like that. They are not hard-coded. Allocation is not done here.
Yeah, unlike in VM we have.
Unlike the VMs. Hardcore allocation of RAM, CPU, hard disk is not given. As and when required, it may pick it up. But again, this is dangerous, right? If it demands more, then the host OS may hang also. That is not our problem. Because you are not going to create any developing any new things or something. Next slide will go. In the diagram, you can see that there is a host operating system which is shared by all containers. This is a host. All containers, container 1, container 2, container 3. Containers only contain application specific libraries which are separate for each container, and they are faster and do not waste any resources at all. See, for example, for this, if it is a virtualization concept, you have given 4 CPUs are allocated, okay, and a 4 GB RAM you allocated. See it in that environment, and near about 500 GB hard disk is given. But this is hard coded assigned to this guy. It cannot be released to the second. As and when the application 2 is demanding, we cannot release that CPU. We may have to shut down, or we may have to remove it. Something like that. We just need to go and disturb the first VM to give it to the second VM like that. So you see the difference?
Yeah.
That's what the problem. So whatever it is assigned already. Hard coded. And it's not the case in containers. You see that it's completely free to use. All these containers are handled by containerization layer, which is not native to the host operating system. Hence, a software is needed which can enable you to create and run containers on your host operating system. This is a layer. And this layer only our Docker, Kubernetes.
Yeah, that's what I was going to ask next.
And so many things are coming.
Okay.
They will handle it. They will handle it. Yeah, they will handle it. Docker will be handling it. Kubernetes will be handling it. Like Red Hat 8 has become Pacman something. There is a new Docker like that. There are so many Docker kind of containers are available in the market. You can take it as whatever you like. But Docker is one of the very earlier one, around 6-7 years it has been there in the market. Everybody is using that.
How do you
in
call
Windows
that?
Also you can install Docker.
How do you call that container manager? I mean container engine that the Kubernetes.
Container engine you can call container engine. Docker is in container.
Kubernetes also called that
cluster. Cluster engine. Yeah, Docker. This is not a Docker. Once you understand Docker, Docker can run in a similar same machine, but Kubernetes will be managing multiple.
Yeah, that's what I'm going to. That I understood.
In a cluster environment.
Yeah. Kubernetes. What Kubernetes is doing? Kubernetes is managing Docker containers, right? Like that. There are some more manage engines are there like Kubernetes. How do you call them as engines? Container engines?
Kubernetes is cluster managing software, you can call it as.
Cluster managing software. Okay.
So this is how the applications are as a containers they are sitting in. You can go to the next slide. Introduction to Docker. This is the Docker engine. It came. You see, this is a Docker engine. This is a host OS. This is a container 1. This is a container 2. Application 1, application 2. Application 1 has got its own binaries and libraries. Application 2 has got own binaries and libraries. But these two containers will be handled properly by the Docker engine. And this Docker engine will interact with the host OS to allocate resources, either hardware or software.
Can a container have more than one application?
Yes, of course. One container.
Yeah.
No. One container contains one application.
Okay.
Second container can have, say, similar application can be run in a multiple containers. That is different. Means like if you are running an Nginx or if you are running Apache HTTP server, like that you can run multiple containers can be running on different, as a containers you can run it. The same application can be run on them.
But
means three Nginx servers can run in 3 containers like that. It's possible, we can run it.
Okay. But Docker engine can handle multiple containers, right?
Of course, that depends on your host OS and the host OS, whatever the wherever it is the machine is installed on that. Hardware dependability is there. Well, how much good is that? That configuration of that host OS where it is running on the machine. 64 core CPU, 128 GB RAM, 4 TB hard disk, something like that. If you have, your Docker will run very fast. Beautiful. But this has got a very good management of this, utilizing the host OS software, kernel, as well as hardware management also, rather than our VM was doing that. Earlier VMs were doing that. So one container running one application at a time. Second container can run the same application, no problem. It will be differentiated by the names and IP addresses assigned to it.
Each container should have an IP address?
Yeah, yes, we can identify that.
It's not that it is assigning to a Docker engine, it's assigning to Docker container, right?
Container level it will assign, yes.
Okay.
So Docker is a containerization platform that packages your application and all its dependencies together in a form of containers to ensure that application works seamlessly in any environment. Is it clear?
Yeah, very clear. And a Docker engine also should be.
If you build it in CentOS, if you build a container in CentOS, you try to run it in Ubuntu, it will run.
Okay.
But we need to verify it when it comes to the Windows environment. It will still work, I'm saying. It will still work. If you build an application on Linux platform, try to run it on a Windows platform, the Docker container, I guess it should be working. That's how the Docker engine is doing some wondering.
Oh, that's marvelous feature, right?
It should be working, but I'm not sure about that. But containers can be like, that's what they can be ported to somewhere, means deporting to some other OS or machines or something. It is very easy. What you do, what the developers will be doing is, they will develop it and then they will give it as like a container. So as an engineer, DevOps engineer, you can send it to the multiple people on this, multiple machines copying another, everything is very easy. Rather than moving with your vMotion and all, it will take a lot of time.
Yeah.
Entire OS is getting moved with all applications. And nothing will, like you are taking a snapshot or something and you are sending it to some other. We already done it in AWS. Correct?
Yeah, of course, yes.
Snapshot of the hard disk and other thing we are taking it. Okay, this is about the introduction to the Docker. Next slide. Each application will run on a separate container and will have its own set of library and dependencies. This also ensures that there is process level isolation, meaning each application is independent of other applications, giving developers a surety that they can build applications that will not interfere with one another. Developers can build a container which has different applications handled on it and give it to QA team, who will only need to run the container to replicate the developer environment. This was I was telling. So entire process is completely kept separate. They don't mingle at all. They are independent of their own things, but still they are using through the Docker engine. They are using the host OS for kernel and hardware utilization or something, but they still kept separate. As a separate process, they will be running on it. We can see the PIDs, process ID will be different. So developer can build a container which has a different application installed on it, give it to the QA team, they can copy it and they can give it to someone. Next, we will see benefits of Docker. Now the QA team need not install all dependent software application to test the code, and this helps them saves a lot of time and energy. This also ensures working environment is consistent across all individuals involved in the process, starting from development to deployment. The number of systems can be scaled up easily and the code can be deployed on them effortlessly. This is what we are doing, like, auto scaling and all we were doing. Correct?
Yeah. Yes.
This is how it has been happening. You can even think that is running on actually in a container only. Auto scaling is running in a container.
Definitely it should be, otherwise it shouldn't come up that so fast.
It cannot go, it cannot that much faster. Yeah, that's what. Booting up time is very faster in Docker.
Yeah.
They may be using Docker or similar kind of a containerization they will be doing inside in AWS, which we don't know. That's why machines are coming up so heavily faster. So it will immediately coming up and filling up everything. 4 systems, 8 systems, 10,000 systems, 15,000 systems and all is coming up faster. Like that. So it is everything is running in a container only. Even our all EC2 machines are a container only. I can say that. Okay, let's go to the next slide. Virtualization versus containerization. What are the differences? Both let you run multiple OS inside a host machine. Virtualization deals with creating many operating systems in a single host machine. Containerization, on the other hand, will create multiple containers for every type of application as required. Major difference is that there are multiple guest operating systems in virtualization, which are absent in containerization. There is no OS. Best part of containerization is that it's very lightweight as compared to the heavy virtualizations. This is the main difference, but we'll see more differences in the coming up slides. Next. Isolation, you can see that. Area. Isolation, if you take it, provide the complete isolation from the host operating system and other VMs in VM environment. In containerization, typically provides lightweight isolation from the host and other containers, but doesn't provide as a strong security boundary as a VM. No. The security issues are still there. Operating system level runs a complete operating system, including kernel, thus requires more system resources like CPU, memory, and storage. But here it is nothing. Runs the user mode portion of the operating system and can be tailored to contain just the needed services for your app using fewer system resources. This is very good line actually. You can see that because it is utilizing still the host OS, but as and when required only it will be utilizing it. Unnecessary, it will not consume everything on its own. Next. Guest compatibility runs just without any operating system inside the virtual machine in virtualization. Runs just about any OS inside virtual machine. Possible. We can install Mac OS, we can install Linux, we can install some other operating system is possible. But in containerization, runs on the same operating system version as the host. So there will be a problem here. Means the applications will be looking for the same operating system. Means like they will be seeing them as the same operating system only, because everyone is sharing the OS level here. There is no different OS installed inside the container. That's why. Then deploying the individual VMs using hypervisor software. Here, deploying individual containers using a Docker, or deploy multiple containers by using orchestrator, that is called as Kubernetes. Orchestration software, that is Kubernetes. Okay. Networking uses virtual network adapters, which we know very well. Here, uses an isolated view of a virtual network adapter, thus provides a little less virtualization. To reachability and other things, we will be verifying that. Next. Persistent storage. Use a virtual hard disk, local storage for single VM or server message block, file share, for storage of multiple servers. We require a hard disk. Use local disk for local storage for single node or SMB storage for shared by multiple nodes or servers. It's a sharing completely. The host OS is whatever it is having the hard disk, it's going to utilize it. Load balancing, virtual machine load balancing is done by running VMs in other servers in a failover cluster. An orchestrator can automatically start or stop containers on a cluster nodes to manage changes in load and availability. Orchestrator is nothing but our KAS. Kubernetes. So orchestrator will be doing the load balancing between the two different containers. But here, two VMs will be doing that. VMS software will be doing your load balancing things. Next. Docker file, Docker image, Docker container. Docker image is created by the sequence of commands written in a file called Docker file. When this Docker file is executed using a Docker command, it results into a Docker image with a name. Yeah, we will see that. When this image is executed by Docker run command, it will be by itself starting whatever the application or service it must start on its execution. It will be starting. We will want to say Docker run and the name of the application we want, container we want. Next. Docker Hub. It's like a GitHub for Docker images. It is basically a cloud registry where you can find Docker images uploaded by different communities. And you can develop your own image and you can upload to the Docker Hub. But first, you need to create an account in Docker Hub. You can go to this link and you can check it. Just go to this link now. Click on that, it will work. Yeah. hub.docker.com. You'll go and create one. Free account, Gmail account you can create. Yes. Build, ship any application anywhere. Sign up.
This is Opera.
Oh, no problem.
Let me once again.
Yeah, every other screen is same only because Docker screen is like this one, blue color, blue and white.
I don't like this one.
Chroma. See, it's
no,
no
that
difference.
comes. I don't want to type over there.
Okay, okay. Remember the password. ID they will give it. Click on sign up. Then they will give the ID. I am not a robot. Tractor. Find out tractors.
Yeah. All tractors.
Next. Synop. Docker idea. No, what is
required?
Type any name like Pradeep something, ITU Pradeep something like that. Maybe it'll work out. Just check.
Mountain or hills? That's all.
Verify. It's happening. Welcome. Log in. Username or email address. Continue. Password. Wrong password.
Verification? Verify email address.
Maybe you may have to go to the mail address and mail must have come. Promotion. Done. Success. Log in. Sign out. Understood. What is this? Sign in. You don't sign in. Sign in. You click on sign in.
Yes, yeah, sign in is here. Came again.
Now it's here. Yes. Download the desktop application. You can scroll down. You can see that Node.js is there. Redis is there. Nginx is there. See that. As a container you can run.
Nginx.
As a container you can run.
Which one did I?
No, you don't need to take. I'm just telling you, like, you need to create something. Then we will go ahead and we will download something. Always scroll down.
Docker desktop has downloaded already. 500 in.
So many of them. See, Ubuntu, anything you can download. CentOS, Python, and many things are there. Registry, something is there.
These
So many applications.
are these containers? So
yeah, these are all containers only. All are containers only.
okay. Oh, Python we can run it in. If I download this on Python, I can run it on a container, right?
Yes, a container you can run. See, you can run
Ubuntu
MySQL.
also we can run in a container.
Ubuntu you can run. Yes.
Sorry.
Ubuntu you can run. Yes, you can run. Hello World you can run.
Wow.
HTTPD, Apache. So with this one, they will be creating a Apache web server and they will set it. That's it. Very simple.
Oh.
As a Docker, we can run it. As a container, we run. Postgres, PC box. See all official messages. You can click on this. Here. Alpine Linux, Ubuntu Linux.
Docker is a Google product, right?
Alpine, no, I guess somebody has created.
No, I mean Docker.
Docker is nobody is actually. It's a freeware actually, free shareware.
Oh, it's not owned by
it
Google.
not belongs to anyone. No.
Oh.
It's open source. Node.js, Hello World, Memcached, OpenJDK, MariaDB, Docker, official image.
What is the official image?
Go along, WordPress, RabbitMQ, mail server, multi-protocol like RabbitMQ, console, Nextcloud, HAProxy. See, HAProxy is nice.
Oh.
Proxy server, and it does some load balancing also. High performance. 500 million downloads easy.
Oh God. Wow,
1.1, 1.7 stars. More than 500 million downloads. It's happening. People are downloading and they start using containers.
1 billion plus.
See that. RabbitMQ. Billion plus it is going.
Oh God. 10K plus stars. Ubuntu.
17 days ago.
Updated only 17. See, this within 17 days is 1 billion plus downloads, right?
That means they will be keep on updating something on this. That's why it is saying 17 days ago. This is the total downloads. Not only this is 17 days ago, that is total downloads since it has been inception like that. And now it has been introduced to this. Do you see that? This is 2 months ago it is saying. No? Still it is saying 1 week. Like that.
Kubernetes belongs to whom?
Nobody.
It is also no.
It's open source. Again open source. Google was actually, they promoted that Kubernetes. But there are third-party people out there, they will provide support for you. Third-party support, you can get it for your Kubernetes installations and other things.
Okay.
Okay, let us go back to the PPT. There's a Docker web. Okay, next. You can share it if you're a developer. You can share your own containers. And Docker architecture, it consists of Docker engine, which is a client-server application with major three components. Server, which is the type of long-running program called daemon process. REST API, which specifies the interfaces that programs can use to talk to the daemon and instruct it what to do. A command line interface client, Docker command. CLI uses the Docker REST API to control interact with the Docker daemon through scripting and direct CLI commands. Many other Docker applications use the underlying API and the CLI. How do they architecture like that? How it is performing the work? We can see when I am running the Docker commands and what is actually happening. So there are three things. One is a server, another one is a client like the REST API, third one is a command line interface. Through this, your Docker is constructed like that. We need to install Docker first. Then we can pull the containers on that. Means a Docker engine need to be installed in your operating system, and it should be running in your operating system as a service. Then you will use your Docker commands to pull and push the containers from to the remote and local repositories.
What I downloaded is Docker engine, right?
Docker engine, yes. We will install Docker engine, install Docker. That engine will be installed. That engine is like a hypervisor, but it is not a hypervisor. Like a hypervisor, I'm telling you, because it's easy to understand for you. That Docker engine will handle all the Docker containers on top of it, and it will maintain. And we can use the Docker engine to pull or push the containers from and to the local as well as remote repositories. Next, Compose is basically to run multiple Docker containers as a single server. Suppose if you have an application which requires WordPress, MariaDB, PHP, MyAdmin, you can create one file which would start both the containers as a service without the need to start each one separately. It is really useful, especially if you have a microservice architecture. So as a single server, we can run it with all three applications running on WordPress, MariaDB, PHP, MyAdmin. Actually, there are three things are running in one single container like that.
One single container?
Means one start we can do that. Microservice architecture like that. So you can create one file which would start both the containers as a service without the need to start each one separately. So WordPress is one, MariaDB plus PHP is one. There are two applications of that. But we can start it as a service to start like one container like that we can start. But actually they are running as a two different containers only. Take it in that way. As a single server, we can make it up because WordPress is dependency on MariaDB and PHP. MyAdmin is required. That's fine. Next, installing in CentOS. So we'll say check update. Any updates is required for server, we can see that. Then we'll have to install this. Yum utils, device mapper persistent data LVM2. This is a required library. Then we'll add the repository. That repository from the Docker CE. Container, something like that. It comes in. Because we are running in Linux, we'll take Linux CentOS. We are in Linux, we are in CentOS. Then we'll run the command sudo install docker, then start the service, then enable the service. Even after restart, it will automatically start. Then check the status of it. These all coming as like a dependencies. This is installing software. This is start and stop. Got it?
Yeah.
Next. It's an Ubuntu platform. How do you install? Because we've seen in CentOS, sudo apt get install. This is the command we need to use. These are all required. And downloading that something Docker for Ubuntu, we see that. Ubuntu.
But if you use sudo su first, then we can use apt get directly. Right?
That's possible. That's possible. And add repository. Same similar step. You see that certificates we are downloading, and GPG key we are adding it. Then adding the repository. Then update we are doing. Then we are installing the Docker C. Simple. All steps are same only. Commands are here and there different. Next. You are writing something? That's all, Docker. We will go for installation. Come on. You can close this PPT.
Okay.
Keep this PPT with you.
I have yeah, we are going to install that in Linux, right? When I downloaded that desktop one, right?
Maybe in Windows, huh?
Okay. But now we are in